started with less than 10 people. For the last 80 years, we are more than 300,000 employees for now. We are the number one in terms of memories. And see, we are number one for the OLED. And also, we were set number one in terms of TVs for now. One of the biggest strengths of R&D in Samsung is we can make eco-friendly quantum dots. I believe we are number one in that area. Actually, it's used in the quantum dot TV, by Samsung, and I think we are the only one who can make this cadmium-free quantum dots. And, I think it's one of the few that initiated by R&D by small group and extended in the successful launch to the main product. So our institute is going to keep working on this area. Normally, at first, I'm very interested in the nanomaterials. So once I joined here in 2002, my first project was quantum dots. After that, I thought that in the future, plastic engineering, plastic electronics might be the future. And I was, actually I'm from the semiconductor industries, not very familiar with organics at the time, but at 2002, Professor Heger, I got PhD, Nobel Prize for this conducting polymers. That's the time that I got interested in the organic materials. And the reason I choose OLED material is it's because it's going to have a big impact on the market once you're developing molecules. I still believe OLED is the first product commercially makes an impact on the industry with organic forms. The organic semiconductor is not actually useful in the industry. OLED is the first one, and everybody said that the solar cell is going to be the next, but it's not launched yet. The solar cell business has tumbled. So that's the reason. I started with OLED, and in the future I want to go for the transistors, maybe CMOS image sensors, and so on. So I try to make some impact on the industry with these organic methods. Well, at the time, we can process it low temperatures, and probably once incorporated with inkjet printing or this kind of wet process, probably you don't need those expensive process such as photolithographies and probably dry etching. So, my former president always said that it's going to be the fourth wave in terms of process technology, printing. So it's all additive printings, and it's very low cost. You can make it in a large area, and I believe that organic is the best match with these kind of technologies. So that's why I believe it's going to be a big impact in someday. It's not there yet. It's actually the speed of development is quite slower than we expected, but I think that's getting close. This material, especially this blue phosphorescent materials, people has been studied for last 20 years, but was not successful yet. So for ourselves, we also synthesize several hundred materials per year to get the long life molecules, but it is not successful yet. Of course, we showed a lot of progress recently, but it's not enough for market launching. One of the technologies that we like to develop is so-called inverse design, using a lot of computer simulations. Usually, you got the molecules and you predict the properties. That's how people work for now. In the future, what we want to do is once if you input the material properties, what you like, then computer will give you the molecule shape. So normally you got molecules and properties, it's been calculated. This is normal technology development. But in the future, after this AlphaGo things, a lot of people try to get inverse design. So if you type in whatever the lifetime you like, whatever the efficiency you like, then computer suggests certain type of molecule designs. So that's what we are trying now. It is called material informatics, and we call this inverse design.